Michaelis-Menten Kinetics is an important concept for biochemistry, and it's also a high-yield concept for the MCAT. And at first, it can seem pretty complicated, but my goal today is to explain it to where you can walk away from this video feeling confident about the topic. At this point, you should know that enzymes help speed up reactions by lowering their activation energy. Very simply, the Michaelis-Menten equation looks at how fast a reaction goes based on how much substrate is available. And on the y-axis, we have the velocity of the reaction, and then on the x-axis, we have the substrate concentration. What you can see is that this reaction is hyperbolic, meaning that initially when you put in substrate, the velocity of it shoots up a lot, but eventually it flattens out and kind of comes to a plateau at its V max. This plateau happens because there comes a point where the enzyme can only work so fast. So no matter how much more substrate you put into the reaction, the enzyme is fully saturated. It's working at its absolute maximum capacity. There's a few sites on this graph that are worth memorizing. The first, which I kind of mentioned already, is Vmax, which is the maximum velocity of the reaction. And this is when all the active sites of the enzyme are full and the enzymes are working at their maximum capacity. Another landmark worth mentioning is the Michaelis constant, which is Km. And this describes the enzyme's affinity for the substrate. Or, more simply put, you could find it as the substrate concentration at which you reach half of your maximum velocity. The equation for Michaelis-Menten kinetics is over here. It's the initial velocity is equal to Vmax times the concentration of substrate divided by the Michaelis constant plus the concentration of the substrate. And depending on your professor and what they want, I wouldn't put so much emphasis in memorizing the equation itself, but rather what the equation stands for. And this lies within being able to interpret the Km values, the Michaelis constant values. If the Michaelis constant, Km, is low, what that tells us is that it takes less substrate to get to half of Vmax. If the Km is low, that means that the enzyme has a high affinity for the substrate because it takes less substrate concentration to get to half of Vmax. Because remember that Km is equal to half of Vmax. The opposite is true as well. If the Km is higher, let's say it was somewhere like out here, what that tells us is that the enzyme does not have as much affinity for the substrate because the Km value would be out here, meaning that Vmax would take longer to get to. So obviously the curve would look a little bit different, it'd probably be a little bit sharper. But point aside is that it would take more substrate concentration to get to that Km value, which is, again, equivalent to half of maximum velocity. And really, as far as interpreting the graph goes, that's about it. Don't overcomplicate it. It's not that hard when you break it down. All you have to do is look at the Km values, and that will tell you if the enzyme has a high affinity for the substrate or a low affinity for the substrate based on where this lies on the x-axis. That's all I have for today, so please like and subscribe if you like this video. Leave any comments if there's something I left out or you feel is incorrect. I'm always open to suggestions, and I hope to see you in the next one. Thanks.